How is the definite integral related to the area? So I'm going to assume that you've already watched the video, What is a definite integral? Because I'm going to focus on some of the concepts in this video. Also, it's helpful if you've watched the video about the height of a graph. We have this graph of the constant function, v of t equals 15. This graph forms a rectangle. And the area of a rectangle is height times width. The height of this rectangle is going to be 15 because that is how high it goes from the x-axis. The width of this rectangle is 1 because that is how far our time goes. So the area is 15 times 1, which is the height times the width. But also, if the y-axis is velocity and the x-axis is time passing, then the height of the graph is the velocity and the width of the graph is the time. So our area is also velocity times time. But this is also equal to distance. So when we are finding our distances on these intervals, we are also finding the area of the rectangles. Cool, huh? So let's go back and review in the video where we're adding up these tiny distances on these little intervals of dt. So we have one of these small intervals that we're going to take a look at. Let's check the height of this rectangle. The height is just the height of our graph, v of t. And our width of the rectangle is just the small time interval, dt. So taking the area of a rectangle is just the height times the width. Our width is dt, and our height is v of t. But what is velocity times time? It's the distance traveled. So taking the area of each one, so when we're finding the distance on these tiny intervals, we are also just finding the area of each rectangle. So when we are adding them all up, we are adding up the area to get the total area under the curve to the x-axis.